Okay, this is going to be the quarter 2 sample test. Okay, I'm going to go through this pretty quickly. All this material was covered this quarter. Okay, for this one, that's a cube. Here's my key points: 1, 2, -1, -2. That's going to be 1, 8, -1, -8. Now my anchor point here is 0 over 1 up. Remember, if it's outside, it follows. Okay. Now, since I have this 2 in front, I'm going to multiply 2 times these things. Okay. Now, what's going to happen there is that's going to be 2, 16, 2, -2, -16. So from here, I'm going 1 right, 2 up, 2 right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, this one is 1 left, 1, 2 down, then 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. All right, let's do that again. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, a little bit off the page. All right, but we get the curve there. All right, division here of polynomials. What I'm going to do is I'm going to start with x -2 here. I'm going to fill in x cubed. This times this is x squared, which gives me -2x squared. All right, I need this to get to 4, so I'm going to have to add 6x squared, which gives me 6x, which makes that -12x. Now, I want to get to -7, so I'm going to have to add 5x, which gives me 5, which gives me -10. That is the same as that. So what my result is x squared, okay, plus 6x plus 5. That is my answer. Okay, that is division. Okay, all right. For 3 and 4, factor completely. Okay. All right. What you're going to have here is you're going to have a box. X to the 4th, -64. The two numbers that would add up to -64 are, and that would also add up to 0 would be -8x squared and +8x squared. So what I'm going to have here is x squared and x squared. Okay, that's going to be, in order to get that, I would need -8. In order to get that, I would be +8. So I'm going to have x squared minus 8, x squared plus 8. Okay, what you're going to have to do here, the GCF is going to be 3. Okay, so I'm going to be left with x squared minus 3x minus 4. All right, you can do this a couple of ways. All right, we have learned that you can convert zeros. All right, so I'm going to equal. All right, I'm going back and doing degree 2. That's 1, -3, -4. All right, now if I solve that, those are my solutions. So my factor is going to be x minus 4 and x plus 1 with the 3 out in front. Okay? All right, moving on to this. It says if x is -3 is a solution, which of the following apply? X plus 7 has to be a factor. Remember, they change signs. -7, 0 is the x-intercept. Okay? X equals -7 is a root. These are all synonyms, okay? These are all synonyms. Let's go to the next page. All right, for 6 through 8, use the following, okay? Which of the following, which are roots, all right? Well, this is going to be a double at -2. That's going to cross at 1, 2, 3, and 4, okay? So what I have is -2 is a root. But actually, hold on, it's not just that. It's a multiplicity of 2. And 4 just crosses as it is, okay? That's that answer. The reason why is that touches, okay? That's just going to touch, all right? Circle the number of turn points, okay? So if I go back to my picture here, I've got 1, 2 turn points, okay? I've got 2 turn points, which means the lowest possible degree it can be is 3, okay? The number of real roots. I have 3 roots because that's a double, all right? 3 real roots. Okay, so if the degree is 3 and I've used up 3, that means that's got to be 0. Okay, which of the following are characteristics of all that apply? It is a cubic function, okay, and it is positive. The reason why it's positive is it follows that pattern of those 2 endpoints, okay, being exactly the same there. Okay, moving on to the next page. Identify all the sets. Okay, that's going to be. What you want to do there is work yourself up from the bottom up. All right, we have a big thing. We have complex. Got complex numbers. Okay, there's real, then there's rational. Okay, then there's integer, then there's whole, and then there's natural. Okay, this part's imaginary. Okay? They also have irrational numbers. All right? Now, since that is a decimal, that's going to be a rational. It's going to be real, and it's going to be complex. Okay? I'm going to go ahead and skip number 2 for now. You can get that stuff in class. Okay? Factoring these, the common thing there is going to be 4x. All right? If I take out 4x, what I'm left with is x squared minus 9x, all right, plus 20. Okay? You can either do box factoring, or I can go back to this, and I can do 1, negative 9, and 20. All right, that means if the zeros are 5 and 4, that's got to be there. Don't forget your 4x. Okay, factor completely. Okay, all right, once again, you're probably going to have to do boxes for this, or you could find the zeros. All right, there's no GCF there. All right, so what I'm going to look for is the number of 36 that could multiply to give me 36 and add to that. That's going to be 6. Okay, so when I do this one, I got 9x squared, I got 6xy, 6xy, and 4y squared. Going across right here, that's going to be 3x. Okay, this is going to be 2y. This is going to be 3x and 2y, and you can double check that. That's 3x plus 2y, 3x plus 2y. Okay. Could you have found the zeros there? Yes, and then put the y's in? Yes, and converted them. Okay. What is the factored form of this? All right. Well, I know the first one is going to be 3x plus 2. Okay. And what I'm going to do is I'm going to use division. How we get the rest? Okay. That's going to be 9x squared, which leads to this being 18x squared. I don't have an x squared term, so that's going to be negative 18x squared, which makes that negative 6x, because that times that's going to give me that, which makes that negative 12. Once again, I don't have a negative 12, it's got to be positive. So that's going to be 4. That's going to be 8. So my factors there are 3x plus 2, 9x squared minus 6x plus 4. Okay? And that's 5. Okay? 6, same thing. All right, I'm going to be at 2x minus 4. Actually, what I should do here, first of all, is I should take out an 8. Okay, so that's going to be part of my answer when I get done. So that's x cubed minus 8. Okay? All right, so my first set of factors is going to be x and negative 2. That's going to be x squared negative 2x squared. I need a positive to cancel those out. So that would be 2x. All right, which make that negative 4x. This is positive 4x. That would have to be 4, negative 8. So my factors are x minus 2, x squared plus 2x minus 8. Okay? These evaluate. All right? So what I want to do is I want to go back to this screen. I want to go to menu. Okay? All right, now I'm going to go to option. I'm going to go to complex. Okay, and this is a simple I to the 34th. I get negative 1. Okay, don't outthink yourself there. Going down to number 8. Since this has a negative, that's going to be negative 7i. Now if I break that down, that's 3 and 25, 5 and 5. I'm looking for pairs. This times this would be negative 35i square root of 3. Okay, 9 and 10. 9 and 10, I'm staying at this complex area. I'm 4 minus 10i, okay, minus 4 plus 2i. And that gives me a result of negative 12i. Okay, moving down to number 10. Okay, I'm negative 7i, 4i, minus 8. 28 plus 56i. Now, how do we get there again? I went through that quick. If I'm back at this blank screen here, all right, I go to option, okay, option, complex. That gets me to that screen. Okay, number 11, okay, number 11, what I want to do there is I want to turn this into 2i square root of 15 times I square root of 10, okay? So I'm going to have 150 on the inside. Now, go ahead and multiply those. You need to do 2i times I, right? Okay. So that gives me negative 2. okay? So when I break this down, that's going to be 2 and 75, 3 and 25, 5 and 5. There's my pair. That times that would give me negative 10. That's the leftover, which is 2 times 3, which would be 6. Okay? 12. Okay? All right. 12. All right. I've got 23 minus 14i times 8 plus 2i. 212 minus 66i. Okay? What is the conjugate? Multiply by its conjugate. Well, if I got this, the conjugate is just this with the minus sign. Okay? And all I got to do is multiply that. 5 plus 3i, 5 minus 3i. That gives me 34. Okay? Find the solution. Now, the key thing here is these all have to be over. So if that's positive 3x, that's negative 3x when it moves to that side. That's negative 5 equals 0. Okay? Now, let's see what that's going to give me. I'm going to go into menu. I'm going to go into equa. I'm going to get into the polynomial. I'm going to have a degree of 2. I'm going to have 6, negative 3, and negative 5. Let's see what happens here. Okay, so this is a nasty one. Now, we're going to probably want to reduce this using the quadratic formula. So I'm going to go back. I'm going to put in my A, B, and C. So alpha A is going to be 6. Actually, I'm sorry, I should have done that backwards. 6 is going to be alpha A. So arrow, alpha A, enter. Negative 3 is going to be alpha B, enter. And negative 5 is going to be alpha C, enter. Okay, quadratic formula. B squared minus 4 alpha A, alpha C. Okay, I've got 129. Okay, square root of 129. All right, I don't know if that's going to get any smaller. Let's check. 129 divided by 3. 3 and 43. I think that's as small as it's going to get. So what I'm going to have is 3 plus or minus the square root of 129 all over 6 times 2. Okay, which is going to be 3 plus or minus the square root of 129 over 12. Now, you'd be probably okay with your answer with that, but if you broke it down to this, that would be okay as well. All right, so that's the solution there. 15, find the zeros for the following function. Okay, all right, you can go into here, menu, equa, all right, polynomial, degree 2. I got 5, don't have a middle term, got 50. Okay, so what I have there is I don't have a real 0, okay? So what I'm going to have to do there, I would do solve by square roots. Okay, so that 50 would come over to be that. I would divide by 5. That's negative 10 equals x squared, plus or minus. So what that's going to tell you is I'm going to be at I plus or minus square root of 10 all over x. 10 doesn't get any smaller. Describe the nature of these roots. Okay? Describe the nature of these roots. So what I'm going to do is if I go back into, there's a number of ways you can do that. You could graph it if you wanted to. That's one way to take a look at it. If I deleted that and did 3x squared, all right, minus 6x plus 4, and drew it. All right, as you can see, it's not going to touch. So what that means is I'm going to have 2 complex roots. Okay? If the quadratic equation has one double root with a multiplicity of 2, then which of the following? Okay? Well, it's this one because it touches right there. All right, only one spot. All right. The graph of the quadratic is shown below in set notation. What are the zeros of the related quadratic? Okay. I find that hard to see there. That looks like negative 2. Maybe 1, 2, 3, 4. I mean, that's fine. Just to write it that way. That's fine. Okay. Set up the quadratic formula to solve the following equation. All right. So they want me to do that. So what I'm going to do, all right, setup wise, I'm going back to the blank screen. All right. I'm putting negative 2 for A, alpha A. I'm putting 12 for B, alpha B. I'm putting negative 5 for C, alpha C. Okay. B squared minus 4 alpha A, alpha C. Okay, whoops. B squared minus 4 alpha A, alpha C. Okay, so what I'm going to have is plus or minus the square root of 104, okay, over negative 2 times 2, and that's going to be negative 12. They might want you to write that out, which that was just 12 squared minus 4 times -2 times -5. Okay, it's another way to do it. Okay, solve, like I said, you might want to check that in the equa section. In the polynomial, it's a degree 2, it's 1, all right, 7 and 9. Okay, all right, nasty answers, nasty answers. So we got to find out what that's going to reduce to. So I'm going to go back to the menu. All right, I'm putting 1 in for alpha A. I'm putting 7 in for alpha B. I'm putting 9 in for alpha C. Okay, I'm doing b squared minus 4 alpha A, alpha C. Whoops. B squared minus 4 alpha A, alpha C. That gives me 13. So I got plus or minus square root of 13. I got -7. And I've got 2 times 1. Now 13 won't get any smaller, just 1 and 13, so I didn't have to reduce that. So that's going to be -7 over 2 plus or minus 1/2 square root of 13. Okay. Solve the following. Okay, once again, always check. Menu and equa. Okay, this takes you about 20 seconds to check, and it can save you a ton of time. That's degree 3. Okay, I'm going to be at 9, 0, 81, 0. Okay, and it says solve. I've got answers of 3i, 0, and -3i. All right. Once again, let's try to see if we can do this. So what if this one's a nice one? Let's say that's we're going to go back and we're going to select polynomial degree 2. 1, 0, 49. If I solve that, 7i, -7i. All right. Okay. What are the factors of that polynomial? We've been doing this a lot. That's going to be x plus 3, x plus 2, x. That's what 0 is, and x minus 4. All right, if a polynomial has a 0 of that and a 0 of that, can you figure out what the other 0 is? The other 0 has to be x equals 3i, okay? Because those are conjugates of each other. What are the 3 ways to decide if this is a factor? All right, well, you could do division and get no remainder. All right, just list a couple ways. You don't have to list 3. If 6 is a solution, that's how you know. Given the polynomial and one of its factors, which is the other factor, okay, well, what I can do there is go into the menu, into equa. I'm going to go back. I'm going to select degree 3. I'm going to type in 1, -8, 1, 42. Solving that, those are my solutions. Okay, so my other factor's got to be x minus 3, which is going to be that one. Okay, all right. State the end behavior of that polynomial as it approaches infinity. Okay, once again, these are these odds, evens. Oops, I'm really in the picture there. Hold on, let me get rid of this. Let's go somewhere over here. Okay, this is odds, evens, positives, negatives. Okay. Since that is an odd exponent, it's this. Since that's positive, it's this. So as x approaches infinity, which is that right arrow, that is going up. Describe the types of solutions of here. Okay. This one we go back into this. Solve 1, -3. No, whoops. 1, -3. 2, 5. Okay. So what I got there is I got 2 imaginary and 1 real. That's that one. What is an equation of the graph in factored form? Okay. Well, that's at x equals -2. That's at x equals 4. Okay. So since that's a double root, I'm going to be at -2, -2. I'm sorry, +2, +2. And then that's going to be at 4, which is x minus 4. So here's my answer. Here's an example of the polynomial in factored form. Okay. You could write it as x plus 2 squared if you like. By what number should you multiply so your result is a real number? The conjugate. The conjugate is just this with a change sign. Okay? Simplify the following. Okay? All right. I got 2 and 36, 2 and 18. Okay? 2 and 9, 3 and 3. Here's a pair. Here's a pair. Okay? That's left over. All right, so I got 6 square root of 2. All right, if I take 12 and divide it by 2, I get 6, so that's x to the 6th power. If I take 33 and divide it by 2, I get 16 with the remainder of 1. So it's going to be y16 with y1 on the inside. All right, this is going to be, cube root of that is going to be negative 4. 13 divided by 3 is 4, remainder 2. Okay, so I'm going to have negative 4x4, cube root of x2. All right, 10 divided by 3 is going to be 3, remainder 1. And the y's inside. And 8 divided by 3 is 2, remainder 2. And that's that answer. Okay, on this one, all right, what you're going to have to do is break that down. 3, 15, 3 and 5. That's going to be 3 square root of 5. This is going to be 2 and 40, 2 and 20, 2 and 10, 2 and 5. Okay, so my leftover there is going to be 5. But I got 2 times 2 times 3. So that's 12. So I got 3 square root of 5 plus 12 square root of 5. Since both of those are the same, that can be 15 square root of 5. Okay? This one, you're going to have to do the boxes for. I'm going to do that right here. Okay, 5 square root of 2, 3 negative square root of 2. That's going to be 15. 3 square root of 2. That's going to be negative 5 square root of 2. That's going to be square root of negative 4. Well, square root of negative 4 is just negative 2. Okay, 15 minus 2 is 13. 3 minus 5 is negative 2, so you got negative 2 square root of 2. And the last couple, write the simplest radical form. I need both of those to be the same, so I'm going to make that into a very simple 21. Okay, so I got 4/3 and 3/7. Well, I'm going to multiply that by 7. I'm going to multiply that by 3. So I'm going to have x 28. And for y, I'm going to have 9/28. Okay? Now, that's a 21 there. Okay? So I want to break that down. All right? Well, what's 28 divided by 21? Well, that's 1 with a remainder of 7. So what I'm going to have is x7, y9 with a little 21 right there. Okay? Write the simplest radical form. That's going to be 7 to the 1/3, 6 to the 3rd, because that's a cube root, y to the 9/3. That doesn't get any smaller. That turns into 3. That turns into 3. I think that's it. Okay? All right, fast and furious there. All right? So go through that packet. You've seen that stuff before, and just practice it, and you should do well.